In this video, we're going to cover what is a BTU or ton of air conditioning or refrigeration. What does it mean? What is a BTU? The capacity of everything from refrigerators to air conditioners is rated in BTUs or tons. You also have various gas appliances rated in BTUs, like a gas stovetop. So what is a BTU and how do they relate to tons of air conditioning? First of all, what does a BTU stand for? It stands for British Thermal Unit. The definition of a BTU is the amount of heat required to raise the temperature of 1 pound of water 1 degree Fahrenheit. It doesn't matter whether you are heating or cooling. It's the same definition and calculation. 1 ton of refrigeration or air conditioning. So how did they come up with the term tons? This comes from the fact that a ton, which is 2,000 pounds, of ice will absorb 288,000 BTUs in 24 hours, a full day. And since everything is rated by the hour, all the equipment, air conditioners, refrigerators, everything's rated in BTUs per hour. So we need to divide the 24 hours to get the equivalent of 12,000 BTUs per hour. So 288,000 BTUs divided by 24 hours gives us 12,000 BTUs per hour. That's what a ton relates to. So ice has a latent heat of fusion, meaning how much heat it will absorb per pound. It will absorb 144 BTUs for every pound. So in a ton of ice, this is all working back to get our BTUs per ton. In a ton of ice, you got 2,000 pounds times the latent heat of fusion, which is going to give you 144 BTUs for every one of those pounds. You just do the math, 2,000 times 144. That's where the 288,000 BTUs come from. That's where the 2,000 pounds of ice at 32 degrees will melt and become 32 degree water. So if it's still hard to wrap your head around just how much a BTU is in relation to everyday common items around you, here are some interesting facts about various outputs of BTUs. So, heat generated by people. One of the factors contributing to heat gain of a space or in a building is the people in it. Depending on what people are doing, they generate various amounts of BTUs. The more active, of course, the more BTUs are going to be burned or added to the space. So you can see if you're sitting, this is total BTUs, meaning sensible and latent. You're burning 400 BTUs per hour. Standing, 450, moderate dancing, 850, and athletics, 1,800 BTUs per hour. These values come from ASHRAE, the American Society of Heating, Refrigeration, and Air Conditioning Engineers. Then you got heat generated by lights. With the transition away from incandescent lights, there is a corresponding savings in the heat output. A 100-watt incandescent light bulb puts out about 341 BTUs per hour. The conversion is for every watt, you have 3.412 BTUs. So it's just a math calculation. And then the equivalent in lumens of this 100-watt incandescent would be like a 15-watt LED. That 15-watt LED would be putting off 51 BTUs per hour at the same conversion of 3.412 BTUs for every watt. Now, you got refrigerators, you got air conditioners, you got gas appliances. When looking at refrigerators or air conditioners or gas appliances, you see the total BTUs, but you have to realize that this is the amount of heat that can be absorbed or produced within an hour. It's an hour they're talking about. It's BTUs per hour. So you can see in this image here, air conditioners are advertised using 3 different indications of its size. The first one here shows 24,000 BTUs for this little mini split. Well, we know 24,000 BTUs. We can compare that to the one next to it because we know 24,000 BTUs is a 2-ton unit because there are 12,000 BTUs in a ton. So that's 2 tons. And the second one there, it already tells you how many tons it is. And you can determine the BTUs because you know each ton is 12,000 BTUs. 3 tons times 12,000 BTUs is 36,000 BTUs. So you can see the second one there is 36,000 BTUs and the first one is 24,000 BTUs. So now you can compare them. Obviously the second one is larger. And then the third one there, they give another nomenclature. They just say 24K. Well, in this case, K stands for 1,000. So that's 24,000 BTUs. And once again, that's a 2-ton unit. 24,000 divided by 12,000 is 2 ton. So number 1's a 2 ton and number 3 is a 2 ton. And the one in the middle there is a 3 ton. So with refrigerators, there's almost no mention of capacity in terms of BTUs or tons. Instead, it's all about the width or cubic volume of the interior space. How much food can you get in the refrigerator? You don't worry about the BTUs as it's assumed that whatever size refrigerator you buy, it will be able to handle the heat from whatever you decide to put in it. So I don't think anyone's ever bought a refrigerator and asked for 48,000 BTUs. They're always looking at the size, so it fits in their cutout in their kitchen, or the cubic volume. That's how they compare one to the other. And then the amenities, of course. And then with gas appliances, with gas stovetops or other gas appliances, it's important to check out the BTU rating of the total unit. And for each of the individual burners, as can be seen in the image, the advertised information is related to the appliance's size. Of course, the size is important when selecting a stovetop or gas appliance, but so is its BTU capacity. The larger the BTU burner capacity, the faster your food will cook or your water will boil. Check the specifications of the appliance to see what each burner is rated for. It could be anywhere from 500 BTUs per burner, or a small little burner, to 18,000 BTUs per burner. It's a big difference, and it's all about the speed about providing those BTUs, transferring those BTUs into your food or your water or whatever you're cooking. You can see in the image here that the burners vary in their diameter, which is indicative of their BTU capacity. The calculation is simple when trying to determine how many BTUs are required for any amount of water. Just take the weight of the water in pounds and multiply it by the difference of where the temperature is before adding or removing heat and where it is when you're done adding or removing heat. For example, you take the weight, the pounds, times the temperature difference equals your BTUs. For example, if you had a gas stove and one of its burners was rated for 5,000 BTUs, you could calculate how long it might take to heat your water, realizing and ignoring that there are losses to the surrounding space. So not all that heat from the gas is getting into your food. So not all heat gets absorbed, but just for simplicity, this is how the calculation would work. Starting with 2 pounds of water at 65 degrees Fahrenheit and wanting to raise that to 210 degrees, which is just short of boiling. Boiling is 212. So the BTUs equals weight of water times temperature difference. So we're going to replace that with the information we know. We have 2 pounds of water and we want to get it to 210 minus 65 is our starting point. So that's 2 times 145, that's 290 BTUs. To take 2 pounds of water from 65 degrees up to 210 degrees. Now, how long is that going to take with a 5,000 BTU burner? Ignoring, of course, that not all the heat gets transferred to the product. So 290 divided by our 5,000 BTU per hour burner says it's going to take 0.058 hours or 3.48 minutes. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.